Last thing in this section, we'll see some more application problems. Okay, so as we see these, we'll remember these phrases, and I know I've said these before, but we're just going to, re-emphasize them again just because they're so big. We use the word derivative, but that can mean different things in different questions. And so I want you to be able to recognize, okay, I read that. I know they're really just asking me for the derivative or the derivatives involved in this. So, we've got our notations, right? So a question might say, find f prime of x, right? That means they're asking to find the derivative, or it might say y prime, or any of those notations. You might see the phrase the instantaneous rate of change, right? We've discussed that already. You might see them ask for the velocity, or if they're even more specific, you might see them ask for the instantaneous velocity. So if you say velocity, that's implied to be instantaneous velocity as opposed to average velocity. Okay, so you might see either of those, or you might see slope of the tangent line. These all mean the same thing. They all mean the derivative. Okay, let's see what our example has for us. It says, at a gourmet candy store. That's pretty cool. Customers buy X pounds of fudge per day. My family likes fudge at the fair and different places. X pounds of fudge per day at price P dollars per pound as given by this equation. Okay, so this is from economics. It's called a price demand function. So X equals 10 plus 180 in this case, 180 over P. So here in a price demand, P is the price, and X is, in our case, how many pounds of fudge they're going to buy per day. So the price per pound, how many pounds get bought. There's an inverse relationship going on there, right? Makes sense, right? The more they charge, the less they're going to sell. And the less they charge, the more they're going to sell, right? And so we see that here in this function. You don't necessarily have to recognize that, but it, right, just kind of connect common sense to it. If they charge more, they don't sell as much. Okay. So you've got your price, P is the price, X is the demand, how much they sell. Okay. So what are we asked here? Find the demand when the price is set at $2 per pound. There's actually not any calculus just yet. We're just kind of getting used to this idea. What's the demand when the price is $2 per pound? Well, that means P equals 2, and we just plug it in. X equals 10 plus 180 over 2. Sorry, that 180 is kind of small. Well, that'd be 10 plus 90. That'd be 100 pounds. If they charge $2 per pound of fudge, they're going to sell 100 pounds that day. That's not too bad. $2 per pound. You know how much fudge that is? I think it's a lot. It's quite a bit. It's a good chunk there. Okay. Here we go. Find the instantaneous rate of change of demand at price $2 per pound. Now we're talking about the derivative. The instantaneous rate of change. So we're saying, okay, let's say we set the price at $2, but we're wondering, like, is that the best? Is that, we want, if we're running this candy store, we want to sell the most fudge we can, or, well, I should say, we want to make the most money we can, typically. And so we want to set the price just right, or at least have a good idea of what would make us the most money. So it might be helpful to know, okay, so, if we're thinking to set the price at $2, we might want to know the instantaneous rate of change, because that could tell us if we should actually be charging more or less. Okay, let's investigate this, and we can kind of figure out maybe why that's even true. So, of course, instantaneous rate of change is derivative, and it's at $2. So we want to know x prime of 2. We need to find the derivative, And then we need to plug in 2. How are we going to do that? Ignore this for a moment. Okay. Here's what we got to do. Now, here's another reason why I bring up this price demand specifically. 180 divided by P. As it's written, we can't take the derivative yet. Here's what we need to recognize. 180 divided by P is 180 P to the negative 1. We need to write it as a power of P. 10 plus 180 P to the negative first. That's the same thing as this. Okay. Now we can take the derivative x prime. So x prime will equal, well, derivative of 10 is 0. And plus 180 P to the negative 1. That negative 1 multiplies down. It becomes minus 180 P to the negative 2. Oh. And perhaps it's advantageous to rewrite it as the fraction. The 0 can drop off. X prime will equal, let's just write as negative 180 over P squared. Because that's the same thing as P to the negative 2, right? Okay, personally, I prefer writing it this way when I need to plug in a number. It's just easier for me to think about it like that. All right, so now we're going to do, all right, x prime 2. So let's plug 2 in. So x prime 2 is negative 180 over 2 squared. And we can calculate that pretty fast. X prime 2 is, well, that would be negative 180 over 4. Ends up being negative 45. Okay. So we've answered the question, negative 45. But maybe we're wondering, like, what does that even mean for this candy store and how they should charge for their fudge? Maybe we're wondering that. I'm glad you are. Here's what it means. This represents a slope, right? It's a derivative. So think of it as a fraction, negative 45 over 1. And what would the units of the numerator and denominator be? Okay, so remember slope, it's the change in y divided by the change in x. Typically, here, though, our variables are x and p. So this is like the change in x over the change in p, the way we have it set up. X represents the pounds per day. P was the price per pound. Okay, so negative 45 pounds per day per dollar per pound. And now there's a lot of pers going on. Pounds per day, dollars per pound, pounds per day per dollars per pound. Here's what it's getting at. If they were to raise the price, they would start making less money. Okay, we've got a negative answer here. So if that price goes up, they're not going to sell as many pounds per day. Okay, so it's dropping. Now again, that makes sense, right? If they charge more, they don't sell as much. And so that makes sense. And so there you go. Okay, pounds per day per dollar per pound. That is the end of our section. Go check out the homework.